Let's talk about the carbocations that I introduced in the topic of SN1 reactions. So as I mentioned before, the more substituted the carbocation is, the more stable it will be. So a carbocation that looks like this one, a tertiary carbocation, will be much more stable than a carbocation that looks like a methyl. And there are two reasons for that to happen. They can be explained by using inductive effects or hyperconjugation. Let me explain you with an example what it means. So when we talk about induction, when we talked about acids and bases, we saw that a fluorine connected to an oxygen, just like this one, for example, was taking away electron density from that center. And that was a good thing because when you have a negative charge on the oxygen and you have the fluorine pulling away electron density from it, that is a good way. It's stabilizing it. However, here in carbocations, it's the contrary. When we have an R group that looks like an alkyl, so imagine we have CH3, and then we have the carbocation right in the middle, and then we have CH3, CH3. And the carbocation is there. Alkyl groups, such as these ones, are electron donating. So they are all pulling electron density towards that carbocation. And in that case, that will stabilize the carbocation because you have electron density being pushed, so the electrons are negative, and they are being pushed towards the plus in the center of the carbocation. That will stabilize it. So as the molecule has more R groups, it will become more and more stable. But when you have something like a simple hydrogens around the carbocation, they are not stabilizing the plus sign. Now, the other way of explaining this stability, it's a bit more complicated and advanced, but I'm going to try. So the carbocation looks like this. So when you have an H, there's no extra stabilization. But look at what happens when you have R groups around that carbocation. The carbocation, it's stabilized by a phenomenon called hyperconjugation. And what that is that plus sign, it's stabilized by the other groups that come from the electrons that come from this sigma bond. So we have electrons here shared between the C and the H, and those electrons are not connected to the carbocation, but they are close in space and they are stabilizing that positive charge. So you can imagine that as you have more of those R's around the carbocation and you start having more of those sigma bonds around it, they will start stabilizing more and more the carbocation in the center. But you see, if we go back now to this very simple carbocation, those sigma bonds are not available and they are not stabilizing the carbocation, the positive charge in the center.